I'm Reed Johnson, field engineer here at RoboFlow, and it's kind of my job to help our customers ultimately deploy successful computer vision applications. So from selecting the cameras to the compute, all the way to building models and then deploying them in a robust manner. So I've prepared some slides to kind of walk through on the way I kind of tackle the hardware problem. There's a lot of hardware options out there, from the different types of cameras to all the many different flavors and types of compute. It can be overwhelming at times. So we're going to kind of just walk through on how you might tackle that problem and ultimately help generate a solution for any use cases you might have. So the agenda is, we're going to start with what is needed. What are the core components of the hardware that you need to select for your application? And then we're going to go into selecting cameras, lenses, your compute, and then finish with a little demo at the end. So the hardware decisions, what is needed? It's kind of overwhelming sometimes to think about, what do I exactly need? And you don't know where to start. So I usually break it down into kind of four main pieces here. And these are the four hardware components that almost all applications have. So the first one is camera, the eye of the system, if you will. So this captures the visual data from your environment and then relays it to things such as your compute. The lens, so this controls what the camera sees. So often cameras don't come with the lens, some do, such as IP cameras, but you select the lens and you can kind of refine the area you want the camera to see, get closer, further away, that sort of thing. And then compute. Compute is ultimately what takes in those images. It does the machine learning, the inferencing, and then it outputs results. So what kind of compute do I need? How many cameras do I have will influence how many, or the size of compute I need, those sorts of things. And then mounting seems like a simple one, but it's actually trickier than you might think. Is how can I mount this camera? How can I mount my compute in a robust manner that is going to withstand things like vibration or temperature, those sorts of things. So this is what I usually break it down to, and this is what almost every computer vision application will have as far as hardware goes. So, and then deployment options, kind of from a higher level, these are typically the three main deployment options you have. And there's probably other varieties out here, but it can be broken down into these. The first one is edge. This is where the camera and compute are installed right next to each other. Within maybe 20, 30 feet, those two devices are installed on your manufacturing line or whatever it might be. This gives you the benefits of minimal latency. Since the camera is so close, you get those frames, as fast as possible. And it enables real-time response capability, such as if you want to talk to a PLC or something like that. Edge may be the way to go. Then you have your local server approach. This is where cameras are installed throughout your facility, and they all route back to things maybe such as a server room where you have your server. So you might have 10 cameras in your facility, and they all route back to your server room, and that one server is going to inference and handle machine learning across all of those cameras. This gives you a balance between control, performance, and connectivity reliability. And then the third one is cloud. So you have all these cameras in your facility, and it might be multiple facilities, 2, 3 facilities, and you have all these cameras, and then they ultimately route back, instead of a local server, the cloud. And basically the cloud is where you host your inferencing and your compute. So there's kind of three different ways to look at it. The cloud one is a very flexible and scalable way. However, in a lot of environments such as manufacturing, there's privacy concerns where you don't even want to send your data there. So that's not always an option. So generally, I see a lot of edge or local server deployments. Camera selection. So this is a very high level, and if people are interested, maybe in the future we can do more webinars on specific camera selections or lens selections, that sort of thing. So this is just a very high level take on it. But when you're selecting a camera, there's a few things to consider. And the first one is, what is the target? What am I trying to look at, detect? So also, what is the distance to the target? How far away is it from my camera, and the size? And then how fast the target is moving. So looking at this bottom left here, there's generally two types of cameras out there, a rolling shutter and a global shutter. Global shutter takes the image all at once, where the rolling shutter kind of rolls down from the top. It takes the pixels and then rolls down. So you get this sort of warping effect there. And the global shutter, you don't get that. I mentioned that because if the objects are moving really fast, you almost always want to seek a global shutter to avoid that sort of warping. But if you have a slower moving object or static object, maybe you want a rolling shutter, the main trade-off there is the cost. Global shutter cameras are almost always much more expensive than a rolling shutter one. And then also environment. What are the lighting conditions the camera will operate under? How far is the camera from the compute device? So where am I going to be hosting my compute? If it's, a mile away, I can't do USB because USB cameras can only go up to like 15 meters or something like that. And then do I need to protect my camera? What is my environment like? Is there a lot of washdowns? Is there water? Is there dust? These sorts of considerations all will play into your camera selection. And then the bottom right here, quick note, there's a lot of different camera varieties as far as like pixel sizes and sensor sizes. Some are really good at low light. Some are really good at other things. So this is just kind of a quick note here. You're going to see a lot of different sensor sizes out there. Basically answering these questions will help influence the type of camera you want. Lens selection. So once you have your camera, you need to put a lens on it. Typically, if it's an IP camera, those usually come baked in together. You don't have that lens option, but machine vision cameras, your Basler cameras or Allied Vision, whatever it might be, you're going to have to select a lens. So this is a little bit easier once you have your camera selected. You're going to want to think about, all right, what is my distance to the target? In the industry, it's called working distance. And then horizontal field of view, which just means how much of the area do I want to see around that target? So once you know those things and you know your camera, I'm just going to step out of this slide. There's tools out there such as this one from Edmund Optics where you can select your camera. You can select, okay, here's my working distance. Here's my distance away. And then here's my field of view, my horizontal field of view. Here's how wide I want to see. And then you can click this and it will show you compatible lens options for your camera that should work for your application. So it's just a simple tool to really help you select your lens. Compute selection. So this one is a big one, but it all starts with what is your primary goal? What do you want to do with these results? Is it real-time processing? Is it periodic data review where I save batches of images and then every hour I'm going to review them? Or is it sort of a cost-effective scalability where, real-time isn't so much an important factor to me, but I need to scale this up as fast as I can. And that's, kind of a cloud-like approach. After that is throughput or FPS. How fast do I need to process these frames? So in a manufacturing setting where product is moving very fast, I need a high FPS to keep up with that fast moving product. And then latency, how quick do I need that data response? And also how many cameras need to be processed? So in the edge setting, it's usually like one camera to one edge device. Where in a server setting, that could be 10 cameras to one server. That sort of thing is very much going to influence the type of compute you do. Data sensitivity, in a lot of settings, your data is very sensitive. That might rule out the cloud altogether, simplifying your options there. And then how consistent is your site's network connectivity? Do you have a very consistent network? Can you support IP cameras, or is your network going down all the time, or that's just going to not be an option? I need maybe a dedicated network or something like that. So the compute, there's a few different options. You have, in this case on the left here, I have like a Raspberry Pi. This is just a CPU approach where, my throughput, my FPS is very minimal, like 1 or something like that. I might be able to get by with a CPU deployment. And then NVIDIA Jetson deployments. These are these little edge devices that you can put on your factory floor or even server room that can tap into a camera and it processes the data right there relatively fast. So these are very popular. And then finally, your server. This might be a Dell server or something that you have a GPU in, and then it's going to process something like 10 cameras all at once. And this server can obviously be in your server room or if you leverage the cloud. So there are a few different options. And then these are the considerations to really help you narrow down the type of compute that you might need. And then you have your sort of use case dependent add-ons. So not every use case needs this, but do I need to protect my compute? If my compute is out on the factory floor and we do washdowns, I need to wrap that in because a lot of devices are not IP rated, or they cannot get wet, or they can't handle dust, temperature, that sort of thing. So do I need to protect it from the elements? Similarly, cameras, same sort of thing. Do I need to protect it from the elements? Or, we have some customers that just, hey, it's not going to be IP rated, but when we do washdowns, we're going to put this sort of bag over it or something to protect it when we do things like that. GPS, do I need to know where my devices are? Cell module, is this a remote setting where I need cell service because I don't have Wi-Fi or Ethernet or something like that? And then ultimately lighting. Not every application needs additional lighting, but some do. So kind of to wrap it up, here are like the steps that I generally ask myself to really narrow down. So what are you trying to detect? Size of target and desired field of view. What is the area around that target that I want to see? Inspect the environment and determine where you can realistically mount a camera. Note if you need protection for the camera or the compute. What camera and lens pair are going to give me the field of view that I want? What do you want to do with the results? Do I want to control a PLC? Do I want to relay the images to the cloud? And so on. And then where can you realistically install your compute? And then important, I stress this all the time, get IT involved as early as possible. IT needs to be involved when you're installing cameras, and those frames need to be routed to your server room, that sort of thing. So the earlier you get them involved, the smoother the process is going to go. You don't want a surprise when you're like, all right, I'm ready to go into production, and IT goes, nope, we haven't been involved in any of this. So get them involved early as possible. So all of these will influence and narrow down your hardware decisions. Finally, I'm going to go to a little demo here and just kind of recap what I just went over. So over here, I have two cameras. I have this Basler camera right here with the lens on it, and then I have this IP RTSP camera. So this is something like an $80 camera. This combo here is in the order of maybe $500 to $600, this machine vision camera. And we'll see the differences between the two. So here I have a little bit of code. I'm just going to show you the Basler camera here, and we'll just run this. This is running RebelFlow inference, which I'm just basically pulling the frames from the camera and then inferencing them on my computer. So you can see here, we are looking at this target. The image is nice and zoomed in on that target, and we can see. So I'm running just a COCO model, so you're seeing clock on there. You can ignore those annotations. But what I mentioned is we can actually swap out lenses, right? So this is a good lens for this application. But what if I wanted to put on a lens that's going to give me a wider field of view, such as this guy? And on these, there's two different knobs. One opens the aperture, which is how much brightness you're letting in. And then the other one is focus, so you can really get a crisp image of your application. So I'm going to put this on, and we can really see how the field of view changes with the simple lens swap. So you can see it's way more zoomed out. My goal is to detect this target, I would not want this lens, but you can see with a simple swap of a lens, you can get a very different field of view. So I'm going to take that off and then put back on my other lens here. So looking in here, as I mentioned, there's two knobs on these lenses typically. One is your aperture. So as I turn this one, I'm going to let less light in. So I'm going to get a darker image. But I'm going to open this all the way up and get a lighter image for us. And then finally is the focus. So you can see as I turn this, I get way out of focus. But I'm going to turn that until I get a pretty crisp image, and I can start seeing those numbers and see the detections pick up. So that is the Basler machine vision camera. Let's go look at the IP camera. So this is the cheaper IP camera, and this is good for a lot of applications, IP cameras. If you just want to know the relative presence of an object, or maybe the color of the object, but I don't really care to pick out things like text on it, IP cameras can be good, and I'll show you why. So now you see this IP camera. It's got a wide field of view. You can see both of these targets. The downside is I can't adjust the lens here. This is fixed. So this is what it's going to have to be, but it's much cheaper. And you can see the resolution is okay. We're getting some weird sort of warping on these numbers and all of that. But that is the IP camera. And then finally, let me show you both side by side. Run this. And now this is a little small, but you can kind of see them side by side, the comparison. You'll notice the Basler camera is a little dark, but what we can do is actually just take a little light here, turn that on, and I'll bring it over, and you can see we can brighten up that image pretty easily with an external light. Finally, I just wanted to show the difference between, this IP camera. So these are still frames I captured earlier. and then the machine vision camera. So if I wanted to go and maybe read the text on this board over here, you see if I zoom in, these are actually, letters and numbers. I can't actually read any of that. The resolution is very poor. But if I go over to this machine vision camera and I zoom in, I can read these pretty dang well. So this is going to enable things like OCR, object character recognition. So I can actually read these numbers if I want it. This is when you'd go the extra mile to get the more expensive camera when you want to do stuff like this, detect smaller things, finer things. Where an IP camera, if I zoom out, if I just want to detect, this square up here and see if it's red, that's probably fine. But in certain scenarios, if you want to read characters or stuff like that, that's not going to be a really good option for you. So let me go back over here. That kind of concludes the presentation, the demo that I wanted to show. I guess, Jacob, I'll turn it back over to you, and if we want to open up for questions or something.